Welcome back to the channel. Today we will be solving round 949 turtle and an infinite sequence. You are given a sequence of infinite length. Initially a of y is equal to I for every integer I. After every second, the value a of y will become the bitwise OR of its two neighbors and itself. Okay, you have to find the value of a of n after m seconds. Okay, and you are given n and m. Now I'll explain this question how it works. Suppose your initial array is 0, 1, 2, 3, 4, 5, 6, 7 and your n is 4. So in the first operation 4 will become the bitwise OR of this three numbers. In the second operation it will again be these three numbers, but in the first operation 5 was the bitwise OR of these three numbers and 3 was the bitwise OR of these three numbers. So in the second operation 4 will become the bitwise OR of all of these integers, and in the third operation 4 will become the bitwise OR of all these numbers. Okay, so if we go again step by step, 0, 1, 2, 3, 4, 5. Okay, in the first operation 5 will get the bitwise OR of 6. In the second operation 5 will get the bitwise OR of 7. So after two operations 5 will become, well, 5 will have bits of 6 and 7 because it has bitwise OR with those numbers. And so when it will, and then when we will use the bitwise OR of 3, 4 and 5, 4 will get the bitwise OR of 6 and 7 as well. Means basically we have reduced the question to be, uh, we need to find the bitwise OR of all numbers in this range. Okay, so if my n is 4 and I am performing two operations, so I will have to find the bitwise OR of 2, 6. If I had to perform only one operation, the answer would be the bitwise OR of this range. Okay, now since the range are 10 raised to 9, we cannot simply perform a brute force bitwise OR of all these numbers in the range. That will become unoptimal. So we need to find a way to find the bitwise OR in a range optimally. So this is the trick. Okay, if we want to find the bitwise OR between any range x and y, so this is what the approach looks like. We need to check that is there at least one number in this range which has my ith bit set. If any of the numbers within this range has ith bit set, which means the answer will also have ith bit set, right? So we can do this from 0th bit to 32nd bit, and then which all bits are present in this range, we will add 2 raised to that bit value to our answer, and that will be our final answer. So now we need to find a way how can we check optimally that the ith bit is present in at least one of the numbers between this range. You need to observe a pattern first. If we write all the bitwise numbers from 0 to 10, then this is how they look like. Okay, something like this. Now if you check, wait, this is 1. Okay, now the 0th bit is present every alternate number. The first bit is present every two numbers, and the third bit is present every four numbers, which means my third bit will be present 4, 5, 6, 7. It will be not present in 8, 9, 10, 11. It will be again present in 12, 13, 14, 15, and so on. If I have a range of at least 4 numbers, it means कि in at least one number this bit will be set, because in every because for every 8 bits, sorry, for every 8 numbers, 4 numbers have their bit set, right? So if I have any random range of 5 numbers, I am sure that at least one number will have this third bit set, because at max 4 consecutive numbers will not have this bit set. Okay, so that's why this is our first condition. If my if my range is more than this value, then it means ki that bit is set. So I am adding the value. Instead of checking for bits, I am doing 1, 2, 4, 8, 16. Val into equal to 2. So if my range is more than or equal to my value, that means ki at least one number will have that bit set always. So I add the value. Now other cases, like suppose my range is suppose my range is 64 to 65. Now the range size is only 2, but the sixth bit is set 2 is to 6. So my sixth bit is set, right? So how do we know ki which bits are set over here? Because the range is just small. So if my range is small, that means all the bits set over here and over here will come in my final answer. So if this does not work, then I just check if the ith bit is set in L, I add value. If or my ith bit is set in R, then I add the value. And I am checking this for every number 1, 2, 4, 8, 16. Basically for every bit. Okay, that is how I constructed my answer, right? You need to check L, it should be maximum of 0 comma n minus m, not directly n minus m. Okay, so basically uh, quick brief, you needed to find the bitwise OR of all numbers in the range from n minus m to n plus m. So from 0 to 32, we need to check for each bit whether the ith bit is set in at least one number in this range or not. So if the ith bit is set in L or R, it means ki the ith bit is set in it means ki we have got that ith bit set. Else, for the range, we check whether the range size is more than equal to that corresponding value 1, 2, 4, 8, 16, those values. And if the range is bigger than that, because of a pattern, the that particular bit will always be present at least once. And since it is bitwise OR, if the bit is present at least once, it will be present in your final answer. Okay,